Hello, I welcome you all. The problem is coming from the Engineering Mechanics and Dynamics, 14th edition by RC Hibbeler. In this problem, we are being asked to to show that the equations of motion for the spool are this and this, and also to evaluate the constant C1 and C2 and later on determine R at the instant theta equal to pi over 4. The spool is 0.2 kg and it slides down along a smooth road. By this we mean there is no friction between the inner surfaces of the spool and the surfaces of the rod. Right, and this is in the vertical plane. It means the weight will be shown going down, vertical plane. Right, so this is important information. Let's draw the free body diagram. We're going to be using polar coordinates. So we have this is the radial coordinates, and this is the theta coordinates. So this is theta, this is r. The weight, we're going to have the weight. Weight for this, let's say, is going to be like so. All right, and then let's say we have the normal force in this direction like so. We have the normal force like so. Okay, so this is the normal force and this is the weight, right? Let's just show some of the angles here. Okay, so this angle here is theta, and if this is theta, this becomes 90 minus theta, therefore this is also theta there. Okay, so this one here is going to be theta, right? Like so. So let's write down the components for W. So we'll have one component in this direction like so, and another one in this direction. Won't be that very long. Right, let's label them. So this one is W sine theta, and this one is W cos theta. Okay, right. With this information, can begin working the problem. We have the kinetic diagram in that direction, showing the direction of the motion. This is our A arrow, this is our A theta. Okay, so straight away we are going to apply the equations of motion. So say summation of forces in the r direction, this is equal to MAR, right? What do we have in that direction? We do have we do have W sine theta is equal to MAR, right? And this is point 0.2, okay, by 9.81. Sine theta is equal to 0.2 AR, right? And our AR is equal to R double dot minus R theta squared, where our theta dot is equal to a 2 and it is constant. That's what we've been told, right? This is constant, therefore theta double dot will be equal to 0. So to write this just becomes 0.2 by 9.81 sine theta. This is equal to 0.2 by R double dot R double dot minus R theta dot squared, and theta dot is nothing but we can write theta dot is 2 squared R. Okay, let's simplify this. So we can cancel out this and this, then this just becomes R like so, okay, minus 4R, okay, we bring this to the other side, it just becomes minus 9.81 sine theta equal to 0. So we have one equation. Then let's work on the second one. Summation of forces in the theta direction equal to MA theta. And then we do have in that direction two forces. We have W cos theta minus N equal to MA theta. Our A theta is equal to R theta double dot plus 2R dot theta dot, okay, and our A theta is just going to be equal to R by 0 plus 2 R dot by 2. Therefore A theta is just equal to 4 R dot, right? So we'll have a 2.2 by 9.81. This is the equation now that we're writing down. Cos theta minus N equal to 0.2 by 4 R dot, right? Then we want to write this as this just becomes 0.8, this one R dot, okay, we are taking everything the other side, then this just becomes, that's 0.2 by 9.81, this becomes minus 1.962 cos theta plus N equal to 0, okay. Right, so this is, we've done the first part. Of course, this is the equation. which is just similar to, it's the same thing, which we can also just write as just 0.8 r dot plus n minus 1.962 cos theta equal to 0, right? So we are done with the two equations. So now let's move on to the next step, where we need to find those constants. All right. So we have been told that the first equation was solved using the methods of differential equations, and this is the solution here, the equation that represents the solution. So R here is equal to C1 e to the power 2t plus C2 e to the power t 2t, the other one minus the other one, then we have a 9.81 divided by 8 and sine 2t. So this is the solution by using the methods of differential equations. So we have been told that if r and r dot and theta are 0 when t is equal to 0, so these are the boundary conditions. Let's evaluate or determine C1 and C2 and later on determine R at the instant theta equal to pi over 4. So this we can do, right? So let's find the derivative of R with respect to time equated to 0. So being told that R is equal to 0. So R is equal to 0 at t equal to 0 seconds. Okay, and R dot is also equal to 0 at t equal to 0 seconds, and so is theta is equal to 0 at t equal to 0 seconds. All right, so now let's find what this R is. R, okay, let's find first R dot and we evaluate them. These are seconds. These are seconds. I can remove them. Seconds. So R dot, this is the derivative of R with respect to time. So this just becomes C1 by minus 2 e to the power minus 2t, okay, plus C2 by 2 by e to the power and minus 9.81 divided by 8 by 2, then cos 2t. Okay, so let's work out this. So R, okay, at t equal to 0, okay, and this is just going to be equal to C1 plus C2 equal to 0. Then R dot at t equal to 0, this is just going to be equal to minus 2 C1 plus 2 C2 minus, this one cos 0 is 1, so this just becomes a 9.81 divided by 4, and this is also equal to 0, like so, because these are the boundary conditions that we have been given. And we have two unknowns, so we can solve this. We can easily solve this. So we are going to use a substitution method. Let's solve this. So we have C1 plus C2 equal to 0, and we have minus 2C1 plus 2C2 equal to 9.81 divided by 4. So I'm going to sum up this, multiply them by some factor that will eliminate one unknown so that I can easily, so I'll multiply this by 2, this side by 1. Okay, then I'll just sum this up. So let me do that. All right, so this just becomes a 0 there. Then we'll have, of course, C1, the first part, this part goes, so our C2 will just be equal to, our C2 is equal to, we have 4, this is 4C2 is equal to 9, like so. So therefore C2 just becomes 9.81 divided by 16. So 9.81 divided by 16. Now we can use the first equation to find C1. These are the same, just different in sign. So this just becomes minus 9.81 divided by 16. Right, so let's write this function. And when you look at this particular function, it has some hyperbolic functions in it. So let's do so. So we can factor out 9.81 divided by 8, right? Then we'll have e to the power 2t. I'll start with this, then minus e. C1 is the one that is minus there, to the power minus 2t divided by 2. Okay, because this is by 16, then I'll say minus sine 2t. So we know that this part, this part here, 2t minus e to the power 2t divided by 2 is just hyperbolic sine function, right? 2t. And therefore our 2t in this particular case is just equal to theta, which is equal to pi over 4. Okay, it's equal to pi over 4. It's also equal to, if you converted it to degrees, it's equal to 45 degrees. So what I'll do for me is my 2t, you can use radians, but for this one here, it's automatic, is radians. Okay, and then for this you can use radians or you can use degrees, but if you change to radians, use radians continuously. Therefore my error at theta equal to pi over 4. Okay, pi over 4 will just be equal to, grab your calculator, so that is hyperbolic functions. Where is my e? Pi divided by 4 minus e to the power. Okay, sorry, me just do the calculation. Sorry for the delay. Right, so this gives us a 0.1981 meters. Alright, so R at the instant theta equal to pi over 4 rads gives us 0.1981. I think this is about it. We found the value of R. We've also proved the two functions which we found here. Okay, we do have it here, right? Okay, and also have it here, right? I think this is about it, and I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.